Okay, all right. Here we are. All right, last video lesson of the year. All right. Although I'm shooting this a month ahead, so I'm not exactly sure how I want to use tomorrow, which is the day before the regions. But I think today was also graduation day, so I know that as of right now, graduation is supposed to be virtual. All right, it's supposed to happen after school. So I'm not sure exactly whether things have changed or not at this point. Okay, so but doesn't matter. Last new lesson of the year. I think. All right, and I just want to say how proud I am of all of you. We've put in a lot of work this year, you and I, and we got here. Okay, so and the lights went off. Hey, how about that? Hold on. I think the timing of that couldn't be better. I mean, it's like so emblematic of like me making these videos all year. Like that's just one of the things that I had to battle was the sensor system, all right, in the room. So, anyways, yeah, I'm really happy we got here. I'm sure you are too, and also very tired. And I'm really glad you put in the work. Okay, and I really hope that what I do with you guys this year is going to help you for the next 4 years, all right, in high school. And that's always been the goal, okay? All right, so let's start the lesson, okay? All right, here we go. All right, here we go. All right, now let's continue where we left off yesterday. Okay, so yesterday we're talking about step functions. Now, there's a reason why step function was easy. Okay, because I don't know if you remember yesterday's lesson. All right, which is right here. Right? There's nothing to process. I don't know if you realize, like, there's no adding, subtracting, multiplying, dividing. You're literally drawing the situation as a function, but the function doesn't really do anything. All right. The only thing that was, you know, slightly complicated is getting used to it and just reading these like open closed circles, right? So what we're gonna do today then, all right, is kind of like look at a step function and just start like adding some crazier stuff in there. Now, by crazy, what I mean, instead of putting these in there, all right, and I'm not even gonna go over this actually, all right, because again, I don't want to take up too much of your time. Instead of having just numbers, right, and assign them values with a flat line, right? So, for example, for like x is less than 1, right, open circle and going like this and on and on and on, all that stuff. Now we're going to look at three things, all right, maybe four. We're going to look at slope-intercept form, so linear functions. What happens if I add a straight line, right, that's like slanted, right, with a slope, right? Or if we look at a quadratic function, right, so you might get a piece of a curve that's mixed in with a straight line. So for example, like we get this, and then with a straight line looking like that, and whatnot, it's possible, right? Or we look at a absolute value function, right, which means you might get a phi-shaped curve, right? Or you might get a square root function. All right, that's really what we're looking at here. All right, it's some combination of these four things we've learned all year. So it's kind of interesting how, on the last video lesson of the year, that we're kind of putting all that hard work that we put into this together into one graph, okay, which is kind of crazy if you ask me. All right, so now let's take a look then. All right, let's wait no further. Now, here's what I'm gonna do. Let me show you a couple of practice. Actually, I really have two questions followed by one question followed by two regions questions. Okay, so let's see how fast we can go. All right, now let's see. Here I got x squared where x is less than 0. So here's what you do, okay? I thought about this. What's the best strategy for us to try this? Now, on one hand, you could grab it by hand. So meaning like you can go like this. If x is less than 0, right, I could create two table of values. So one for this. All right, I'll use a different color. One for this. Okay, now let's see. So if I got x, the function, the y, and the coordinates, right? If you're doing this by hand, x has to be less than or equal to 0, meaning this. 0 and less than that, -1, -2, -3, so on and so forth. So don't bother with the positive values, just the negative values. You see what they're trying to show you there? So let's try that, all right? Let me make the pen a little bit thinner. Now, x squared, x0, 0, 0, 0, 0, right? -1 squared is +1. All right, so that's 1, -1, 1, so on and so forth, right? And then you could do the same thing for this, right, with the functions, so on and so forth. It's a lot of work, yeah, I know. So let's use a, by the way, there is a way to do this on the graphing calculator where you can just put everything in and they'll show it to you, but I think by showing you that, it's more work actually. So let me show you how let me show you how we can do this, okay? All right, now, let's go to x squared, all right? Let's keep it simple, so I'm gonna go to x squared. Now, I'm not gonna graph it, because if you graph it, it takes all the values into account, and you already know we're not supposed to, right? Because we're only supposed to take 0 and anything less than that. So what I do, yeah, you look at the table of values. Let me make sure I'm recording. All right, okay. Now, which means this, right? 0 and anything less than that. That's what you're gonna plot. So let's try that, okay? So what is that? 0, 0. Now, and I'll color code it too. I'll put one in blue and one in green, okay? 0, 0. Oh, let's see. 0, 0. What's the next value? -1, 1. -1, 1. By the way, that's a quadratic, right? You see that, right? Okay. -1, 1. -2, 4. 1, 2, 1, 2, 3, 4. And what else? -3, 9. I'm already out of space, so I'll stop right here. -3, 9. Probably somewhere up here. All right. Now, I'm gonna connect this because if I leave it at the end, I'm a little more worried that we can't see the overall picture. So I'm gonna stop here. All right, got that? So I got my arrow here. Okay, so far so good. So I got like part of a parabola on one end, right? Basic. By the way, it's also a parent function of that, right? Now let me clear. Now I'm gonna clear this. Don't graph those two together. Okay, actually, you know what? What if we graph those two together and just like pick apart, just mentally erase the parts that are not supposed to be there? I wonder if that's better. Okay, let's give that a try. Okay, why not? -x squared plus 4. -x squared plus 4. Now let's see. So now I'm gonna graph it just to see, okay? What kind of crazy, wait, what happened? What did I do? Oh, I put minus. Oh, I can't believe it. Last lesson of the year. I can't practice what I preach. All right, yeah, negative. All right, don't forget that. Don't be like me. All right, let's see. Graph that. Now, very interesting, right? Because you really have two graphs going on, two parabolas that are facing opposite of one another, right? Now, let me analyze this for a second. You know what? This might not work as well, actually. So here, I'm gonna look at you know what? Yeah, you know what? I'm gonna restart. So I'm gonna clear this, clear that, and I'm gonna put in -x squared plus 4. Because the reason why I tried that first was maybe it's easier to see how the two separate graphs can connect, but I don't think that worked very well. So we'll just stick to this original method. All right, I can graph that. All right, don't look at the whole graph, so I'm gonna look at the table of values. Now let's see what I want. I want where x is greater than 0, right? Now that means here we have an open circle also. All right, and that also means that we have, what is it? X is greater than 0, so it's greater than 0. So 1, 3, like that, 2, 0. All right, 3, -5. Is that right? 3, 1, 2, 3, 4, 5. And I think that's it, all right? Because 4, -12 is all the way down here. Now, I know what you're thinking. Because right now you're thinking, wait, what's going on here? Because I got a line going up, blue line going up this way for the first function. And I got a line that looks like it's going this way. So what do I connect? How do I connect it, right? So this is what you do, okay? Oh wait, I forgot something. At 0 is actually 4. Now, it says x is greater than 0, but I still have to examine that point. All right, so that's my fault. I should examine that. Now, the thing is, it doesn't include whatever that happens to be, the answer to be. So this has to be an open circle. So not down here. All right, let me clear that up for you. The blue here is a solid point, because that includes 0. And for this one, it's an empty point, because it's not supposed to include 0. Think about it like that. And then we got this. It's weird. That's it. That's the graph. Okay. Now, in case you think that, I'm just like making all of this up, I actually have the answer here. Okay. All right. So as you can see, all right. Okay. All right. Now, next question. All right. Let's do 2 regions questions, and then we'll call it a day. All right. Now let's see. Okay. So these are the 2 regions questions. So actually, if you want, I'm trying to think. Should I let you try both of these? I think you should try both of these. Okay, so let's see. Yeah, try, let me get you started on one of these. Okay, and then for number 5, I'll let you work on it entirely on your own. And then I'll show you the answer key. Okay, all right. So now for number 4 here. All right, we have negative half of x. So that means on the graphing calculator, I would have negative half of x. So now I'm going to put it in parentheses, okay? Negative half of x, like that. Now let's take a look just to see what the graph looks like. Okay, all right. Now let's see. Let's go to table of values, because we need to graph this. What do they want? They want anything that's less than 2. All right, so, okay, so why don't you go ahead and get started, okay? So try that and then do the same thing for x. Now, I'm wondering if you know what this means. Yeah, it's just whatever x is, that's the y value. Think of it like that, okay? So think about what that looks like. So in other words, right, what would you type in your calculator for this one? Think about that. Yeah, y equals x, right? So imagine what that line looks like, okay? All right, so when you come back, let's see. When you come back, I'll just show you the answer key, okay? All right, so try that right now. Press pause right now. All right, and we're back. So this is the answer, okay? Now, hold on one second. The lights just went off again. So now, think of it like this, all right? One of the things I actually originally wanted to do was this, okay? So I'm going to use, let me use a straight line, actually. No, let me use this, okay? Now, what I meant originally was this, all right? The green one, right? This is the green one. All right, I'll try to stay consistent. What I originally wanted to do with the graphing calculator was to show you if you put these 2 graphs together, all right, again, no ruler, okay? No ruler. Shouldn't do that. All right, like that, right? And then if you graph this line, it would just simply go through the origin like that, right? That's the original line. But what a piecewise function does is this, is being very, very specific about where you can graph this and where you can't. Think about it like that. It's a series of restrictions on where you can graph. So originally what I wanted to show you was, imagine that you drew these 2 lines with no restrictions, meaning the 2 lines being like these 2 functions, right? These 2 linear functions, right? That if you had we not had these 2 restrictions or domain, specifications, okay, that what would they look like? And then, but with the restrictions, what would you have to do? Well, with the restrictions, you would have to erase them. So for the first one, right, anything less than 2. So how you notice how where x equals 2, you don't want any of that. That's what that's saying. And then whereas for the blue line here, right, anything that's 2 or greater, meaning anything that's 2 or greater, you have a solid line inclusive of the answer. That's what that means. This includes the answer, this one doesn't. That's why it's an open circle for this, and that's why it's a closed circle for this. Okay, got that? Now, again, I would like you to try this next one. right, last question perhaps of the video lesson series for the year. All right, very, very emotional. All right, try this one on your own. Okay, see what that looks like. So press pause right now. All right, and we're back. Okay, so again, right, with the absolute, have you noticed? So with this one, I mean, this is really interesting. Let me use a highlighter. This one's really interesting. Have you noticed, right, for the first one here, absolute value of x, right? The domain is very well defined, right? Meaning from -3, I should use a marker actually. Hold on. From -3, now I know it's hard to see the axis. This is the axis, okay? Let me draw a thicker line. Wait, how do I draw a thicker line? I need to draw an actual line. All right, okay. Right, it's actually from here to here. And then the y-axis from here to here. Okay, is that better? Yeah, that's better. All right, now, that said, what was I talking about? That said then, right, from -3, which is here, I need a pen for that. From here, this is -3 to where x is 1. That's where your function will be visible. You know what, maybe that's another way to say it, right? Where they specify the domain is where the function is visible. How about that? And then the rest is invisible, so you don't draw it. Think like that, all right? So that means for this one, let me just make sure I'm still recording, because I feel like I'm on a roll. So this is all the makings of a, that was cool, that looked really cool. This has all the making of an absolute value function. Okay, but it got chopped off because you're not supposed to be able to see what happens after x is equal to 1. Think of it like that, okay? Now, the second one, think of it like this then. This is basically saying, hey, pick up where we left off and start at 1 inclusive, closed circle, and where the y is just equal to 4, because that's just what this means. Y equals to 4, so you just got a straight line that's just keep going and going. Now, don't draw arrows, okay? Because the function stopped after the graph. It's at 8 down here. So it's got to stop, okay? You can't keep going. Don't draw arrows. Don't keep going, right? It's very, very, very specific, okay? So that's it. All right, that's it. All right, 16, yep, not bad, okay. As I'm wrapping this up, I really, really, really hope you found these videos helpful, all right? I wanted to make sure we finished the curriculum, you know, put you in a position where even if you take the regions, you could do this, and then if you weren't taking the regions, I wanted to put you in a position where, again, that these tools will serve you down the line when you're in high school, okay? So, thanks a lot. Thank you for your work. And yeah, that's it. All right, I'm signing off. Okay? All right, have a good one. Bye-bye.
OMG, that was so good.